There we go. All right, restarted the recording. Now we'll be checking out well through learn. You got a message from a random girl woman. Wow. You have a lot of friends, Jay. Scary part's the name has 69 at the end of the ID. You know that's legit when it has a 69 in the end. Hello, YouTube. So let me open that up. It might be a bit loud, guys, alright? Might be a bit loud. Cover your ears. I haven't tweaked the volume for this yet. Okay, let's go with that. Windowed. No. There we go. Oh, it's a bit blocking there. Crap. September 13th is the day of the programmer. Keep up the good code. What does that mean? Is it like Programmer's Day? So let me deep clear and restart. So we can start from scratch and begin from the really first stage. So we can all be on the same page. You know this game, it was copied from a different game. Oh really? Oh, I didn't know that. So what, where did it come from originally? It's good. I might have to move my face there. We'll see. Tutorial, let's go with that first. Welcome to our game. Tycoon game. Give you an opportunity to take the role of a machine learning specialist and evolve from a rookie to a professional. So in the beginning it's very easy and then it gets pretty complicated, so I'm sure you guys can help me out here with the logic and stuff. Human resource machine. Ooh, I'll have to check that out later on. I wonder what they changed. Maybe it's like a sequel. Clumsy at cat.meow. And it seems like the guys are very into cats, seeing as how the whole reward system is like centered on buying your cat stuff, accessories, shades, attires and whatnot. Nothing changed. How can that be? It's a very weird thing. I would assume that sparked some controversy if they just copied it outright. Even the cats are the same? Running a big social survey in schools, okay. Divide pupils from junior and high school based on their test sheets. So we need to develop a simple program for categorizing them. And then you have a bit of trivia, Eliza, the first non-neural artificial intelligence, whatnot. And then here's like how the game looks like, how it looks like in the game, and how that converts into real life. Things like that. No cats in HRM though. Maybe that's what they added. The cat twist. Drag a block from the list to place it on the screen. Something like that. No music. Very quiet. Drag the socket using your mouse to make the connection appear. Like that. There it is. There's the music. So this is the beginning. We have 10 red, 10 blue. And what we want is to transfer them here. Transfer all the red here. Transfer all the blue here. Yeah, so this is like coding 101. So we pass through. This is the starting point. We pass through here. They call it the expert system. And then we say, if you're red, you go through here. But if you're anything else other than red, you go to this other one. Right? Eliza is a real program. Yes, it's a trivia. It's a trivia from real life they're sharing there. Although I wasn't really familiar with it. But that's good, they have those kinds. And so you see it is getting shifted properly. Yeah, simple as that. So there are a couple of bars here which will be explained later on. We'll go through them one by one. And there's also other things in there. So first you test them, then you see that they're working. And then when you see that they're working, you can then release them fully like that, which will cost a bit because you need to rent servers for running your program. And then it does it in real time, and this time for real now. A Jackson plan. What is a Jackson plan? So you can fast forward. There you go. So we got we spent 42, but we earned 300, so 258 net. No tax. Good. Didn't realize programming was so easy. Yeah, in the beginning. It could be. Task tree displays your in-game progress. Different types of tasks, different colors and icons. Okay. More awesome stuff will start appearing in the in-game shop. Lines, okay. So that's just like the progression. Okay, we'll go through that later. And then some side quests. So like the big cats are the main storyline. The side quests are like nice to haves. When you said nothing changed, you meant as in the concept. Ah, okay. The UN stuff is different. That's good. So it's not a blatant copy. It's a similar concept, which is not bad. I mean, it's not like a very unique. It's a very smart thing, but it's not like no one else can think of it, right? So it's not. I don't take it against them. Jackson plan is what you draw to simulate your program. Oh. How come? I haven't even heard of that, or maybe I forgot about it already. Or maybe that's what I do, but I don't know the name. I do like writing stuff on paper, designing on paper before I do anything else. Okay, so we have one more. Could you predict which of the students will be able to get into MIT? Output. Here you can see requirements to successfully complete the task. That is the amount of data required, so it needs 21. And that is the accuracy. So how accurate the data that comes into it should be. That's the bar, the minimum requirement. So you see it there. So this one needs 100% accuracy, no mistakes, and then 8 green blocks in there. This one blue-green blocks. 8 blue blocks, sorry. So this one is basically the same, but this time we change it to green. Transfer that green there, blue here, and test it first. Easy peasy, lemon squeezy. It's so simple right now, but later on it will get really painful. Clumsy doesn't simulate, I just YOLO it. Good. Earn us 300. So on top of these missions, there's also the startup, and that's an additional twist. I like that entrepreneurial kind of thing there. I wonder who that is. Maybe that's the guy, the developer. Right? Let's try the next one. But that startup thing will appear later on as we progress. Some errors in our questionnaires data. Can solve the problem ourselves? Okay. You will meet different types of medals on many levels. By switching between those medals, you will be able to see additional conditions and restrictions imposed on this task. Get money? Okay, gotcha. There's a trash can now. Real datasets have a lot of errors. Filtering out errors is a very important skill for all data scientists. True that. Almost like HRM, almost. That's fine. Let's leave it. I'll research that later. Thanks for the heads up, Jay. So we have a silver or a gold medal, and to get a gold medal you have to use less of the blocks so that you earn more, and you also have a time limit, a shorter time limit. Time limit goes into play later on. So what is this? So this one, basically what we need are red and green blocks. We have all 3 colors. So what we need to do is we filter out the blue ones. We say if you're blue, you get thrown to the trash can, or if you're otherwise, you go here, right? And it's a bit more complicated, but not really so much. It's an added twist. We're good. So that is the basic premise of the game. And we'll see more twists and turns as we go along. Jackson structured programming. Oh, let me have a look. Example of a JSP program. So it's like a flowchart. A, B, C, D. Ah, yeah, I haven't done this before. Yeah, more like... Yeah, I just get right into the code. And maybe I do some squares as well, but my own structure. Next game. Not a fan, huh? Cat Heroes. Yeah. Okay, another one. Some new types of errors made by our users. It will be easier if you'll use the previous version of the code. Cat Heroes. Yeah, game speed. So what do we do here? We need to use custom node. You can use programs which you've constructed while completing previous tasks, which are allowed to be used for this task. Custom nodes don't waste time on transferring data from one node to another. You may want to optimize them to better fit your current task. I'm not so sure what the use of this is, especially in a very simple solution like this, but I guess it will come into play later. So you like do something inside and then use all that logic on a different program. But we'll see how that comes into play later. And then you also have the runtime here. Like you see that 1 second. So that's why we have a time limit, because you cannot just pick the easiest solutions, because usually the easiest ones are the longest to execute. So if you have a lot of requirements, you will not reach the time limit. Looking way up like that. Well, my monitor is flipped vertically, the second monitor, so it's a bit tall. That may be what you saw. Good. Oh, I think I missed one of the tutorials there. That's fine. So what do we need to do? I think it requires a custom node. So this is the program that we did beforehand without blue. And then we have a green-blue divide, red-else divide. Only red. We need only red. And I can easily just do this, right? But I don't think it will allow me. Yeah, red like that. And then if it's otherwise, to throw it out. In this task, you need to use one of your previous schemes. So it's a requirement. So I don't quite get it because it's not really necessary. So it doesn't like highlight the need for custom nodes. I don't think this is a very good example. So we can do that maybe. And then if it's red, you go there. So it's basically doing the same thing. Because if you go inside this, we'll see that it's it only has one in there. For filtering the red and throwing out everything else. So we go with that. Yeah, that's it. Yeah, vertical orientation. Well, it's actually very good for reading articles and stuff. And yeah, that's also the monitor with the margin, the red margin. Let's release that. So let's play this for a while. Let's wait till we get to the challenging parts. Let's try to solve it, and then I'm happy. Good. Okay, I think it's going to start already. Yeah. Optimization of the code. I love this word, optimization. In my full-time work, I do a lot of these. Performance, the problems, optimizing the problems. It's a very, you can get into it and lose the whole day just analyzing one problem. In game, okay, you have a decision tree color. This is a different one. You can see it's 0.3 instead of the 1 second, but this time you don't have an else. You only have two choices, and this comes with a twist, because if it's like red, so you pick red here, you pick green here, but if, for example, a blue thing comes in, it doesn't fulfill any of those conditions. Yeah, you see here, if it doesn't satisfy any condition, so if we put a blue here when we're only looking for red or green, it moves to a random socket. That's the clincher. That's a bit of a weird behavior from my point of view. Hey Barry, welcome back, man. We are playing something completely different today. Wish you crept your program for a greenhouse that controlled the watering, humidity, shutters that had to auto-generate numbers for each and open-close shutters. On-off to sprinklers. Wow. Now that's a very useful program. Nice. Alright, let's see here. So let me show you what I mean. We can only have 3 nodes here, and we have a very short time limit if we want gold. So 18 seconds is the time limit. So we only need red, but you cannot just do it like that and maybe pick any here, right? You would think that would work. But if you go slower here and test that, you see if there's a blue. Okay, this time it works. Oh, it actually works? No. You see, some of the red ones are actually entering that as well, because we said any. So even the red ones come into it. So it's a bit of a problem. Yeah, so we didn't reach the required number of things in there. Stop. Doesn't work. And if you pick, for example, green here, and we try that, you see that if we come in contact with the blue one, the blue can either go on top or at the bottom, because it doesn't satisfy any of the choices here. It just decides anywhere. Very weird logic. So in here, this is for coding. Now this is like a puzzler, but it's more on the coding aspect. So it helps you get your logic. It helps you train your logic. So let's do it like this maybe. I think I remember what I did here. So filter out the green, and then if it's blue or red, or was it, wait, what did I do here? I think I was trying to filter out with one by one. Green, blue, let's try this, And we cannot just pick an expert system because it's 1 second, it's very slow, and we have a very small time limit. Let's see, there. If it's red, go through. If it's blue, go there. But I think the problem here is if it's red here, coming into this one, it can go to either one, which is not what we want. But let's try it, Yeah, look. The red one is going to the trash can. That's not something we like. Definitely not. So, any suggestion, guys? How do we not get rid of the red ones? interchange it. This is the limit. 3 nodes. Well, 3, how do you call it? Yeah, 3 nodes. Interchange, you mean like that? Right. Where's that coming from? No. So we pick this one. If it's red, go through, right? Can we start from scratch? So what you're saying is if it's red, we go through to the next step, which is this one. But if it's green, for example, you go to the trash can. So what this will do is it will transfer red and blue here, and it will transfer green and blue here. So that's good. So what will come into the second one will be red and blue blocks, and from there we can say red and blue. If you're blue, you throw. If you're red, you go through. Right. So if you try that, then what happens is red and blue come up, the green and blue come down, and then the next step, the blue come down, the red push through. Yeah, so it starts taking shape. Yeah, good call. That's how you do it. Question is, will we make it in time? Yes, we can. Yes. Good. Good job, guys. Don't show me next time. Yeah, so you see it's starting to require a bit of effort in terms of thinking. At least on my end. Maybe on your end it's pretty automatic. So this one, I am not sure if I missed something here. But effort, what's that? No such thing. Yeah, Jay just snaps his fingers. Everything happens already. No such thing as effort required. So yeah, this one is a bit more complicated. More numbers, more nodes, or how do you call these? Yeah, more endings, and very limited time frame. So I guess if we finish this, I'm happy. We can leave it as is. And then we can try the startup, and I'm good. We can jump to something else. But I want to really finish this before we move on. So easy one to use the expert system. Yeah, but it's going to be too slow for that, I think. We can try it first. We'll try it easy. So if it's... And the problem here is you cannot choose 2 nodes to go to. It's only 1:1. Like you see here, it's... if you want red, you can pick red there, but you cannot tell him to also go there. It's a bit tricky. So it's only 1:1. So let's try that. So if it's blue, because blue only needs to go one place. If it's blue, go there. If it's red or green, then let's think about it further. If it's red, go there. But that will limit us to only having red here and green here. How can we say if it's red or green, go to either? We'll say any. Maybe we can say any, right? Because only red and green will come through here. So we don't really need to distinguish between them. Oh yeah, that's right. Green, all 3 of them. That's right. So we're still missing one. So we'd still need to pass through one more, which is, I guess, that one. Just to split it. So we say green, go to that one, and that one. Or if it's any, go to that one. Oh, no, 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 no. No, that's right. Does that work? So blue, that's clear. Blue goes here. Let's test it. The green one will go to this else part, right? And then it will see that it's green here. It will go there. Ah, I think I'm missing something. No, it's good. Yeah, it's good. But I think I need to go... No red will come through here, I think. I need to put it the other way around. Yeah, doesn't work. Stop. And I think it's too slow as well. So maybe this expert system in front doesn't really help. But let's try first. Let's make it work and then let's make it fast. So red and green will arrive here. We want green to be in all of them. So how do we do that? We want red to be only in the first and third, but we want green in all of them. So we can say, if you're red, let's try. I'm missing something. Yeah, this now gets your brain going, doesn't it? At least it gets mine. So the blue one we already have set. The green, you can say if you're green, you go here. And then you go to these two places. But if you're red, you'll go through here. And you'll only go there, but you also need to go there. So I think... can you also go here? But that's going to defeat the purpose. If you're red... How about if red goes here? Then red can go to these places. And green can... No, it doesn't really work, does it? See what I'm missing, but not sure if you can explain it. Add one more decision tree color for red. I think that's right, although we cannot do that with the nodes, we can do that with a custom node. So if we pick a only red fast, that's not the one that we need. But I think that's 1:1. We needed a 1:2. Let's remove the nodes. Okay, let's start from here. Right. So we have any. So we have the red and green coming through here. Right. We want the green to come through not the red. We can have the blue for custom node. Ah. How would that look? We can have the blue for custom node. Blue goes to only one. But how would that be different from the expert system? So let's see. If we go with, except for red and green. Yeah, it's very hard to explain. Let's try that again. But let me not scrap any of these first. Let's start from here. And let me see, let me think. I'll think aloud. So we have the blue one, which is pretty straightforward. We know that we want it there, right? The tricky thing is we need red in 2 and green in 3. So if you want red, let's start from the basic and let's modify from there. I want red here, but that only goes to one place. If I want green here, if I want red here as well, I can do that. And then I can choose. So what this will do, it will transfer red to that place, and it will transfer red and green to this node. And then the red and green can transfer, if you're green, you go there, right? Or if you're red or green, you go here. Does that help? The music makes you sleepy. Let's see, let's try it. Alright, where does this go? Green goes here, yeah, okay. And then green goes up, green goes down, that's good. Red goes in there, that's correct, so everything is 100% accurate so far. Green goes up. That looks good. But it looks like we won't make it in time because this expert system is too slow. Yeah. Yeah, out of time for gold, but if we can make it happen for bronze, maybe that will work as well. Anyway, in terms of accuracy, we're good, but I think we're too slow. Out of time, yeah. So it's working, but it's too slow. Alright, let's, maybe this is the bottleneck, right? Because it's 1 second. So if we can find a way to filter blue in a very fast way, that might help. How about we say, and we need to branch it off, like 2 exit nodes. Green and blue divide. No, that doesn't work. I'm not sure if you can... Only red fast. Without blue. So this one, we filter out blue. But that's, I think, slow. Yeah. All these are slow. Only red fast, this is the only fast one. So we can say, if you're blue, you go through. But if you're not, red, the only fast one. Yeah, that might be something that we still don't have. Maybe that's why we cannot solve it. So I'm not sure if we're missing something. Or maybe it's just really challenging. So if I delete that, how do we make this happen? Because that one is correct. I think that's as fast as it gets. Maybe. And then we want something... If we do it like that, then that won't work. Because that will transfer everything only in one way. And that will only transfer red, so that doesn't work. If we try a decision tree in here, we can say if it's blue, go through. Or if you're red or green, oh, that might work. Red or green. So if it's blue or green, you go there. If it's red or green, you go bottom. That might work. Let's try it. So green goes through. That's good. Blue goes through. Red and green go through there. Yeah, that works fine. It's actually working pretty good, although that's only silver. That's silver. How can we make it gold? Estimated result is silver. Can we remove one of these? So we have that set. That's working. But red going there. Can we remove one of these? Let's just have that. And if it's red or green, just go to any, isn't it? Like that? Would that work? Oh, but yeah, because that green is already in there. Yeah, we already solved the green in the middle. I think that works. Still silver though, and it's lower even. Why is that? Let's try it again. Does it change depending on the type? I don't get that. It became even slower than when we had it before. Let's see what happens. Green goes through. Red and green go through there. Maybe because some of them are going to... Because we need more at the top than at the bottom. So maybe we need to focus more there. Yeah. Maybe let's pick red here. Will that change anything? Not really. Alright, you know how now. Great. Let's hear it. First decision tree, red on top, blue at the bottom. Let's try that. Red on top, blue at the bottom. Oh, it works. Yeah, it works, but it's slow. Ah. One sec. It's to be any. Yeah, second is any. It worked, but we only got bronze from it. What's weird was when I had like one more decision tree, it was faster. We were getting silver. Don't get it at all. I guess maybe we like I see. Maybe we do something like this. So instead of having it half and half, right, we make it like balanced. So 2 nodes go here and only 1 node goes here. Right, so you think of it like this is 0.5 going there, 0.5 passing through here, and that 0.5 gets split further. 0.25 goes here, and 0.25 goes there. So in short, 3/4 of the things that are coming through are going here, and only 1/4 is going here, and that's because we need more stuff in here. So that has more things going into it. If that makes any sense. Let's see if that works. So maybe that's why it was going faster earlier. You were getting silver. Not any. It should still work, right? Shouldn't it? Because they need both red and green. Wait a minute, am I missing something? Yeah, it's still bronze though. What do we need here? We need red. Green and red in third. Green and red in third. What does that do? Let's see. So this one gets red. Yeah, I think we should just fine-tune it depending on how many red and greens there are, so that we can prioritize, like make the red faster in here or something like that. Yeah, that's a bit slow. So 24 seconds. We have more green than we do have red. So we can say green maybe go here, red go here. No, but that's going to limit us. It should be any. Red go here and any go at the bottom, if that changes anything. And then the green one goes through here. And then this one can be any. Let's see how that works. So are we balancing it out? Now what's happening is we're filling up 20 faster than 15 because of that 3/4 thing. It's a bit too much. It's the AI vehicle logic. SES optimizing team trainer. Right. Yeah, so we have it correctly, but we cannot get gold. It's hard to get gold, huh? Yeah, this looks correct, but still a bit slow. We have to min-max it. Let me try something. If we can make it this green. Try that. Just an experiment. Let's have a look. Before the time ends, which one is not filled? Both of them. Yeah, look at that. Now 20 is growing slower because of that thing I changed there. It's quite hard, isn't it? If I just anything, everything. By the time that we're almost running out of time, stop. Oh, you can't really pause it. You can just go slow. Right, let's see. We have so much more in here. And yeah, I don't think we will make it that way. Look at this. I broke the game. Yeah, I think so too. I wonder how I got silver a while ago. Before I deleted stuff. We initially got silver, if you guys remember. Maybe I had green here. I'm just going to try different combinations, right? Right there. Have a good night, Scotsman. Catch you on Friday. Thanks for hanging out. Oh, there we go. Now that's silver. Yeah, that one's silver. We're just making this red and green. Okay, let me go there. Let me bite into that. I'm happy with that already. Take care, man. Clumsy trucking and stay away from those crap fecos. There we go. Press this one more time. Got an achievement for that. Okay, I'm good. I'm happy. I solved it. That was something I was looking at when I was testing this out. And then there's like a startup as well. Oh, what is this DLL thing? Ah, That's what Jack was asking about. Create your own custom node. So the custom nodes, new DLL slots can be bought in C-Bay. Cat Bay, I guess, huh? Ow. I see. Maybe that's how we can maximize it. Make it like blue and something. So that's how. Because in the mission, I think you can have like 3 custom nodes in one, or 3 nodes in one custom node, or one DLL. Maybe that's the key there. But yeah, so you can optimize it a lot. But anyway, I think you guys get how the game works. Startups. I don't think I can show that anymore, but let me just describe it. Startups are similar in a way that when someone approaches you for a startup, you can accept, and then you're basically going to have something similar, like a problem like this. So you have to do something in there, and then you have to make sure it's optimized, and that is like an ongoing thing. Like depending on how optimized the code you put in is, you'll see like a chart here saying how much you're earning because of that, and you'll see if you're like your running costs are too high because you need the server and you're not processing enough data, things like that. And you can have like 4 different startups that will boost your passive income as you finish programming them. Read the inbox and C-Bay. I think these are the ones that are, yeah, this is part of the mission, I think. Hide completed tasks. That might be a bug. Where's the 2? Oh, private. History of expert systems. Bruce Buchanan. I think this is like more of the history lesson. Who invented the decision tree? Yeah, I think so. Very nice. There we go, that's updated. And C-Bay. Hide locked items. Ooh, a banhammer miniature. I like that. 40k. Goodness. Cat skins. An analyst. Get a cat. What is that? When I clicked it, a browser opened, which leads to a Google survey, Google Docs survey. How about this one? It's not yet implemented, maybe. I'm not sure. How about that one? Okay. So can we see it at least? Beauty and harmony. Showing room. Oh, there it is. There it is. It's a bit sneaky. Okay. And then what are the other things that we can buy? Viking helmet. Let's spend all our cat euros. Why not? And then you can buy some nodes as well. Hardware. I think this game is currently in early access. Something like that. And there you go. That's our guy. So at least you have something to spend your money on. You're just not earning it for nothing. There we go. Yes. So that's how the game looks. Yeah. Let's save that and exit. So thanks again to developers for giving me a copy of this one. Pretty interesting stuff. Really exercises the brain. You stop the recording there.